Hello everybody and welcome to Mrs. Baker's Monster paper. This is the paper 2 edition and this is questions 1 to 10. So the element sulfur is found in a number of different minerals. Which mineral contains the greatest percentage by mass of sulfur? So this we just have to put in the work. This is one of those that's going to take longer than 1 minute. We just have to put in the work. So barium is 137, sulfur 32, and oxygen is 16, and we've got 4 of them. Lead is 207 and sulfur is 32. Calcium is 40, sulfur is 32, and oxygen is 16 times 4. And pyrite, iron is 56, and we've got 2 sulfurs, so 32 times 2. Let's work out the MR of all of them. So the first one is 233, second one is 239, third one is 136, and the fourth is 120. So now we work out the percentage by mass of sulfur. So we've got 32 over 233 times by 100. We've got 32 over 239 times by 100. We've got 32 over 136 times by 100, and we've got 64 over 120 times by 100. Well, I think we can see that D is going to be our answer, but we can't just assume. Let's do the sums. 53.3%, 23.5%, 13.4% and 13.7%. So our answer is, of course, D. Okay, question 2. What is the empirical formula of an oxide of iron formed by reacting 2.24 grams of iron with 0.96 grams of oxygen? So we need to do 2.24 of iron over 0.96 grams of oxygen. Divide by 56 and divide by 16 is 0.04, 0.06. Smallest number of moles is this, so divide everything by 0.04. That'll give us a 1 to 1.5. Now, of course, we can't have 1.5 of an atom, so we need to times this by 2 to get it into 3. If we've times that by 2, we also need to times this by 2. Our ratio is a 2 to 3 ratio. So answer must be C, Fe2O3. Question 3. Calcium carbonate is heated. Calcium oxide and carbon dioxide gas are formed. The equation for the reaction is shown. So we've got a 1 to 1 to 1 ratio, exactly 100. So now we can do mass divided by the MR to give us our number of moles. So that's 225 divided by 100 gives us 2.25. So if we've got 2.25 moles of that, we've got 2.25 moles of calcium oxide as well. So if we've got 2.25 moles, then, so this is our calcium carbonate and our calcium oxide. If we've got 2.25 moles of that, we've got 2.25 moles of that. Calcium oxide is 40 plus 16, which gives us 56. Now we just need to times those two together. Should give us a theoretical yield of 126. So we add in our calcium carbonate, we add in our calcium nitrate, and we add in our carbon dioxide. We add in what the question's told us already. We know we've got 25 grams of calcium carbonate. We know we've got a 1 to 1 to 1 ratio, so nice and easy. Let's work out how many moles of calcium carbonate we've got. So for that, we need our mass divided by our MR. Well, we know that calcium carbonate is 100 because we just worked it out in question 1. We know that we do 25 over 100, gives us our number of moles. That's going to give us 0.25 moles. It's a 1 to 1 to 1 ratio, so we have 0.25 moles of everything. Now we want to find the mass of calcium nitrate, so we need to work out the MR of calcium nitrate. So the MR of calcium nitrate is 40 plus 14 times 2 plus 16 times 6, because there's 2 times 3. That gives us 164. So if we've got a MR of 164, we just need to do the MR times the moles to get to the mass. That gives us 41. So it can't be A and it can't be B. Now we need to work out the volume of carbon dioxide. Well, we're now in our vol-mol 24 triangle, so we can do the moles times by 24, which gives us 6. A volume of 6. Answer must be C. So question 5. A student mixed together 25 centimeters cubed of a 1 mole decimeter cubed hydrochloric acid and 25 grams of calcium carbonate. So we've got 25 grams of 25 centimeters cubed of hydrochloric acid and 25 grams of calcium carbonate. What's the maximum volume of carbon dioxide that can be collected at room temperature and pressure? So we've got given stuff about the hydrochloric acid and we've got given stuff about the calcium carbonate. So because we've been given 2, one of them is going to be in excess. So first of all, let's find out which one is in excess. We've been given the concentration and volume of an aqueous solution. So we're up here in the moles conc vol. And we've been given the mass of calcium carbonate. So we're in the mass moles MR triangle as well. So let's draw our table. Let's put in what we need to know. We've got 2 HCl, we've got CaCO3, and we've got CO2. Let's put in what we know already. We've got 25 centimeters cubed, so 25 over 1,000. We've got 1 decimeters cubed here. We've got 25 grams of calcium carbonate, and the MR of calcium carbonate is 100. Let's work out how many moles of each we've got. So 25 divided by 1,000 is 0.025, and 25 over 100, 0.25. So the question is, with our molar ratio of 2 to 1, if we wanted to use up all of the calcium carbonate at 0.25, we would need 0.5 moles of hydrochloric acid. Well, we've got nowhere near 0.5 moles of hydrochloric acid, so our limiting reagent is the hydrochloric acid. Therefore, it's the hydrochloric acid that we use to calculate our moles of carbon dioxide. Our calcium carbonate is massively in excess. So let's have a look. 0.025 moles of that, divide by 2, gives us 0.0125 moles of carbon dioxide. And now we've got our 0.0125 moles of carbon dioxide. We times that by 24. And that will give us 0.3 as the volume of carbon dioxide. So the answer must be D. Okay, which gas sample contains the smallest number of molecules? So we've got He, a monatomic, we've got O2, diatomic oxygen, we've got CO, and we've got nitrogen, N2. So in this case, it's given us all in grams, so we're up here in the mass moles MR triangle. 4 divided by 2 gives us 2. 16 divided by 32 gives us 0.5. 28 divided by 12 plus 16, which is in fact 28. So 28 divided by 28 gives us 1. And 28 divided by 14 times 2, which is 28, gives us 1 as well. So the smallest number of molecules is actually the smallest number of moles. The answer must be B, because we've only got half a mole of that. Question 7. The equation for the combustion of ethane is shown. And so we've got 2 ethanes with 7 oxygens, makes 4 carbon dioxides and 6 waters. Which volume of carbon dioxide at RTP is formed when 0.5 moles of ethane burn? So we've got a 2 to 4 ratio. And because both are gases, we're going to use the gas triangle, which is the vol-mol 24. So let's work out how many moles of ethane we burned. 0.5. So we need vol, mol, 24. We've got 2C2H6 and we've got 4CO2. We need to work out the volume of carbon dioxide. So we've got 0.5 moles of that. We've got a 2 to 4 ratio. So we've got double the amount of carbon dioxide. So 0.5 times by 2 is 1. So we've got 1 mole of carbon dioxide. Now that we've got the moles, we can just do moles times 24. Moles times 24, so 1 times 24 is 24 decimeters cubed. The answer must be B. Okay, question 8. Sodium carbonate solution reacts with dilute hydrochloric acid, and the equation for the reaction is shown. We've got excess sodium carbonate, and it's added to 10 centimeters cubed of a 0.1 mole per decimeters cubed hydrochloric acid. What volume of carbon dioxide gas is made? So we've got a 2 to 1 ratio. Now we can ignore the sodium carbonate because it's already told us that it's in excess. So we're in our aqueous triangle here, moles conc vol, because it's given us concentration and volume. And we are working out the volume of a gas. So we need this gas triangle, the vol mole 24. So we've got the moles conc vol, and we've also got the gas volume and 24. So 2HCl and CO2. So we've got a 2 to 1 ratio. We can put in the 24 into our table. We put in what the question tells us. We've got in our volume, we've got 10 centimeters cubed. So 10 over 1,000 gives us 0.01. Now, if we've got 0.01 of a concentration of 0.1, we times those two together and we get 0.001 moles. If we've got 0.01 moles of that, we've got half of it for the CO2, so we divide by 2, 0.0005. Now we've got our moles of carbon dioxide, we can just times by 24, so it's already on our calculator, and that gives us 0.012. So we've got 0.012 decimeters cubed. We now need to transfer that into centimeters cubed, so we must times that by 1,000 to get it into centimeters cubed, which is 12 centimeters cubed. Answer must be A. So question 9. Sodium hydrogen carbonate undergoes thermal decomposition. What's the maximum mass of sodium carbonate that can be made from 0.1 moles of sodium hydrogen carbonate? So we've got a 2 to 1 ratio, and we know that we're looking in for the mass, so we must be in mass moles MR, and it's given us the amount of moles of sodium hydrogen carbonate. So it's just 1 mass moles MR. Let's put in what the question tells us. We've got 2 NaHCO3 to 1 Na2CO3, so we've got a 2 to 1 ratio. We know we've got 0.1 moles of that. So if we've got 0.1 moles of that, we've got half the amount of the sodium carbonate. So we divide by 2, gives us 0.05. The MR of sodium carbonate should be 23 times 2 because we've got 2 of them, plus 12 plus 16 times 3. Let's do that. That gives us 106. So now all we need to do is times the MR and the moles together. So times 106 by 0.05. And we get 5.3 grams. Answer must be B. Question 10. Which sample contains the greatest number of molecules? Again, we've got to work out the number of moles to make an inference about the number of molecules. This has given us 2 in grams, so mass moles MR triangle, and we've got 24 decimeters cubed of oxygen, so we've got the blue gas triangle as well. So hydrogen is H2, water is H2O, oxygen is O2, and carbon dioxide is CO2. So in this case, we've got the mass divided by the MR, so 4 divided by 2. We've got 18 grams of water, so we've got 18 divided by the relative molecular mass of water, which is, of course, 18. And we've got 24 decimeters cubed of oxygen, so we've got 24 divided by 24. And we've got 66 grams of carbon dioxide. So we've got 66 divided by 12 plus 16 times 2. So let's do that one first. 12 plus 16 times 2 gives us 44. So 66 divided by 44. gives us 1.5 moles. 24 divided by 24 gives us 1. 18 divided by 18 gives us 1. And 4 divided by 2 gives us 2. So what's the greatest number of molecules? Well, that's the one with the greatest number of moles. The answer must be A, 4 grams of hydrogen. Question 11. Benzene is a liquid with a molecular formula C6H6. Ethene is a gas with a molecular formula C2H4. Which statement is correct? So we're going to do process of elimination on this one. Is it that 1 mole of benzene and 1 mole of ethene contain the same number of atoms? Well, how many atoms have we got here? We've got 6 plus 6, so we've got 12 atoms there, and we've got 2 plus 4 here. That gives us 10, so A is definitely not right. Is it 1 mole of benzene and 1 mole of ethene, both of a volume of 24 decimeters cubed at room temperature and pressure? Well, it's told us that ethene is a gas, but it's told us that benzene is a liquid. So that would only be true if they were both gases. So, B, you're no good. Is it that both benzene and ethene have the same empirical formula? Well, if we distill these down, we get to CH because we can actually divide both of them by 6 to get 1. So the empirical formula for benzene is CH. And ethene, we can divide both by 2 to, if we divide both by 2, we get CH2. So, sorry, C, that's not correct. Is it that the number of carbon atoms in half a mole of ethene is equal to the Avogadro constant? So in 1 mole of ethene, I'd have 6.02 times 10 to the 23rd times 2, because I've got 2 carbon atoms in my molecule. So therefore, if 1 mole is times 2, then half a mole, or 0.5 moles, is 6.02 times 10 to the 23rd times by 1, which would be equal to the Avogadro constant of 6.02 times 10 to the 23rd. So our answer must be D.